We started this study essentially by accident. So we went out to the Boulder Atmospheric Observatory to measure the volatile organic compounds, brought all of our instruments, and as soon as we turned them on, we realized that we were seeing much higher values for some of these compounds than we had expected to see. For instance, propane values were 3 to 7 times higher than any of the other cities that we had compared to, and the maximum values that we saw were comparable to what we saw in the Houston Ship Channel during a summertime study in 2006. And here we are at the Boulder Atmospheric Observatory, and there seemingly isn't much around you. It's a suburban site north of Denver, so we're seeing these very high levels, and we couldn't tell exactly where they were coming from at first. But a quick, essentially Google search let us know that the site is within one of the 10th largest oil and natural gas fields in the entire United States. And so that's when we started looking into the source signature and the emissions from oil and gas operations in the area. So with the instrument that we have, we can measure up to 200 different compounds. For this study, we quantified 60 of them. And we do that because we know that there are multiple sources. So in the Front Range, we looked for the signature from urban emissions. We've looked for the signature from biomass burning. During the wintertime, people often have fires in their fireplaces. We typically look for biogenic emissions, so VOCs, they're emitted by plant life and agriculture and nearby farms and so on. So we looked for all of these different sources, and as it turns out, several of the hydrocarbons that we measure were all equally elevated, and they correlated very well with one another. And so that led us to believe that all of these were coming from one source. And what we were able to do is compare that source signature to raw natural gas composition. And as it turned out, the raw natural gas composition matched exactly what we were seeing in ambient air. You know, with our group here, we don't do any kind of health studies. What we're interested in are the atmospheric impacts. So the very high levels of these compounds, they were very commonly found in the atmosphere. Again, things like ethane and propane that you would use to light your gas grill at your house. These compounds generally are not known to be toxic in and themselves. But what made them interesting to us is that because they're so abundant, it actually makes them a better source for ozone precursors. And that is a molecule that we study quite often here. So in order for us to understand ozone formation, we have to understand the compounds that contribute to that. And these compounds can contribute to photochemical formation of ozone.